Alright, now we'll cover angles and rotations. This is section 5.3 in your textbook. Now, an angle is the union of two rays with a common endpoint, and that comes from geometry. Here's your angle. Now, in trigonometry, however, we think of an angle as a rotation. So if I draw XY axes and I start along the positive x-axis with the endpoint at the origin, draw a ray here, and I rotate it counterclockwise, that would be considered a positive rotation, like so. Then I have an angle. This is a positive angle. Now if I rotate it clockwise, I have a negative angle. So this is negative, and rotating it counterclockwise is positive. So you could go either direction, and you can have negative angles in trigonometry. The initial side, as we call it, of the angle would be the starting point. That would be this ray here. And the terminal side would be this side, or this ray here. The angle that is formed is said to be in standard position, and the measure of an angle, or a rotation in this case, can be given in degrees, which were invented by the Babylonians. They divided up the circle into 360 equal parts, which are called degrees, and one complete revolution then of this ray would amount to 360 degrees. 1/2 of a revolution to this point would be 180 degrees, and 1/4 of the way around would be 90 degrees, and so on. Now, you could have possibly greater than 360 degrees in trigonometry if you keep rotating. So if you go beyond 360, you could have more than 360 degrees. So you're making more than one rotation around this XY axis system. And of course the same thing applies with negative angles. If two or more angles have the same terminal side, then the angles are said to be coterminal. For example, if I take this angle, let's say it's 30 degrees, and I rotate it another 360, what I have then is 360 plus another 30 is 390 degrees, and the angles are basically the same. They end up in the same position. So 390 degrees is coterminal with 30 degrees. The same thing would apply to a negative angle. You could go the other way around clockwise and end up at this point, and those angles would be coterminal. So, for example, let's find two positive and two negative angles that are coterminal with 51 degrees, say. Two positive and two negative angles. So what you do is you add and subtract multiples of 360, just like I did in this little illustration. So for example, you could go 51 degrees plus 360 degrees is equal to 411 degrees. So if you start out at 51 degrees and rotate that 360 degrees around, you end up with 411 degrees, which would be coterminal. They're in the same position. Another example would be 51 degrees plus 3 times 360 degrees, and that would equal 1,131 degrees. So 51 degrees and 1,131 degrees are coterminal. So you would go 3 times around. You would start here and go 1, 2, 3, and you would end up at 1,131 degrees, which is in the same position. If you want a negative angle that's coterminal with 51 degrees, you could subtract 360. 51 degrees minus 360 would look like, would be negative 309. Start here, go to the clockwise direction, 360 degrees, and you would get negative 309 degrees. Or you could do a multiple of 360. 51 degrees minus 2 times 360, for example, would equal negative 669 degrees. So basically you start with your angle 51 degrees plus or minus some multiple k of 360 degrees, where k is an integer. Alright? So all of these are coterminal with 51 degrees. Now, we have certain special angles, or types of angles. For example, we have a right angle, which you all have heard of before. A right angle is 90 degrees. And it's often symbolized by putting a little box in the corner of the angle. We have acute angles. Acute. These are angles between 0 and 90 degrees. So if you call this angle theta, which by the way is often used to denote angles in trigonometry, we use Greek letters, angle theta. An acute angle would be between 0 degrees and 90 degrees. In other words, theta is greater than 0 degrees, less than 90 degrees. We also have obtuse angles, which are between 90 and 180. So that would be obtuse. And theta would be greater than 90 degrees and less than 180 degrees. And a straight angle is 180 degrees. Now, historically, an angle has been expressed in degrees, minutes, and seconds, similar to time. So there are 60 minutes in 1 degree, and there are 60 seconds in 1 minute. So sometimes we need to convert to decimal degrees, or degrees, minutes, and seconds notation. So degrees, minutes, and seconds is the traditional notation. But decimal degrees are becoming more useful these days, especially with the advent of computers. And so it's often helpful to be able to convert between one and the other. You can do this automatically if you have a grapher. For example, if I want to convert something in degrees, minutes, and seconds format, for example, 5 degrees, 42 minutes, and 30 seconds. By the way, minutes are symbolized with a prime mark up here in the superscript, and seconds have double primes in the superscript. And of course, degrees are symbolized by the little circle notation there. So 5 degrees, 42 minutes, 30 seconds. We'd like to convert that to a decimal degree. You should be able to do this using a calculator, a graphing calculator. On mine, I would enter 5.4230, or just 423. And I would press HMS, which means hours, minutes, and seconds. I know that has to do with time, but it's similar to degrees, minutes, and seconds. HMS arrow means convert from degrees, minutes, and seconds into decimal degrees. I would press that menu choice, and I end up with 5.708 and 3333 and so on. So about 5.7083 would be the solution, or rounded off to 2 decimal places. This is approximately 5.71 degrees. Alright, now you're going to be expected to be able to do this yourself on a test. So you either can use a calculator, like I did, or you can do it the old-fashioned way, by hand. I'm only going to show you the hand or manual method one time in this example, and from then on I will expect you to be able to do it. Now, if you don't have a calculator that can do this for you, you're going to have to do it by hand, so pay close attention. Now, we have 5 degrees, 42 minutes, 30 seconds. Change that to a decimal degree. So this is equal to 5 degrees plus 42 minutes plus 30 seconds.